has been pulled on your eyes.
I say a little prayer for you.
I think I'm all set up. Okay. All right, yeah. So in this session, we're going to be going through Gatekeeper 1. It's looking interesting from the start, so we'll spend some time digging through it. And if we don't complete it in, I'll do a part 2 if I don't complete it. But if I get to a total of about 3 hours of attempting a challenge, then I kind of call it quits and look at the write-up. So just to recap, we worked on privacy in the last challenge. This is a really great one to learn about how Solidity's storage works, how to grab storage at a specific slot, and then also casting bytes 30, like casting different data types. So yeah, we did that challenge last time and use an attack contract to do some things, but that's the last one. So for this one, I'm going to go ahead and clear this out as we usually do. Let's go ahead and clear all of that, and we're going to rename this Gatekeeper Gatekeeper 1. Let's go ahead and call this contract. Actually, we'll pull that in. This is before I do anything. Let's go ahead and pull this code in here. Okay. I probably need to make sure I have in NVM version 16, node 16. Okay. All right. Let's go ahead and yarn Hardhat. Let's clean this up. Okay, got some issues in here. Okay. We're not going to worry about that for now. And we're going to try to do this locally first. So let's take this out. Let's take this out. Let's take, I don't even need that. Need that. Don't need any of this, honestly. All right. Um, we just have to change some things around. So let's go ahead and just take a look at this challenge first. Let's take a look at how we might need to set up our test, and then we'll jump into the code. Hardhat. So make it past the gatekeeper and register as an entrant to pass this level. Okay. So hmm. So things that might help. Remember what you've learned from the telephone and token levels. So in telephone, what do we do? In telephone, our transaction origin cannot be equal to message dot sender. Okay, so we have to use a externally owned account to call the some type of contract, which then calls change owner. Okay, and then they said token, and for token, we had to create some overflow situation. Wait. Yeah. So we had to use an overflow situation to get more tokens than we should have. So we go back to gatekeeper 1, make pass the gatekeeper register entrant to pass this level. I don't see any type of overflowing here, but okay. Okay, I remember what I learned. Gas left and slate documentation here and here. Okay, what's this gas left? Turns remaining gas. Hmm. I've been interested to know about gas left because of gas griefing type of attacks where you can send just enough gas to make one transaction work, but a call could fail silently, and that would be successful gas griefing. And I've heard that this gas left is how you do it. Like I know the concept of the attack, but I actually don't know how to um, implement that kind of attack. So been wanting to learn this. Now, interesting thing that I'm a little confused about off the rip is how can I determine what gas is needed when hitting this second function, especially because of like the demand at the time, depending on the blockchain, depending on Ether's network activity, the gas price can be a little different. But we can, okay, that's right. while gas may be higher, you can still submit a certain transaction and a miner can choose to pick it up or whatever they want to do with it. So okay. I wish they had a message. Hmm. Yeah, it'd be nice if they had a message in here, but maybe I can do that on my own. But let's see if does console log in Hardhat change bytecode. I don't know. I was thinking what I could do is add a console log in here and um, see if it hit that. Or I can just, that's right, I can just deploy my own. That's what I can end up doing. All right, so the approach of this attack in my head right now, it's got to be a few things. Um, so okay, let's start here. Attack flow. So the first thing we're gonna need to do, shit. All right, so the first thing we need to do is send a transaction from a contract and not directly from an EOA, externally owned account. That's going to be the first one to pass that first gate. Okay. Message.sender is not equal transaction.origin. Because remember, if transaction.origin comes from the original initiator of a transaction and message.sender is just the last uh, object that called this function that this modifier is on. So also another thing is a modifier is a way for you to like implement certain requirements or access control. This little underscore here just basically says run this require statement and then continue with the rest of the code, which in this sense would be, where do they use it? Wait a minute. Okay, I was like, where do they use this? Um, would be here, and the underscore basically just says like run all this stuff afterwards. So we know we have to send, okay. So we know we have to send a transaction from a contract and not directly from an externally owned account. Next, we have to send is there a way to just get this exactly at 8,191 gas? Um, maybe figuring out how much this transaction cost. Oh no, 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 no. It was previously known as message.gas. So maybe we have to send it with exactly 8,191 way and somehow message.gas. How can I make my transaction be submitted with that amount of gas? I guess I'll learn that. So I'm guessing just send in my contract account, my contract function. I'm gonna somehow send a mess, or whenever I invoke this enter, I'm going to make sure I send that message with a certain gas price. Hmm. What Solidity version is this? 8.0. Can I send a... Hmm. I want to know how to actually modify that. Um, hmm. So maybe in my original call, I have to figure that out. Uh, Hmm. I need to figure out how to perform a gas creeping attack. That helped me out. I get gas prices and so easy mimics. Transaction gas price. A transaction with a gas limit of 100,000. How is that possible? Using the gas keyword. Okay. So I can send a transaction. All right, so that's what I was trying to figure out. A little confused on how. Let's just try something real quick. So I'm not really understanding this gas keyword. I don't see how it's using. So is it like the gas limit 200? Well, where am I using the gas keyword? You went. What is the gas limit? Maximum quantity of gas. Gas limit. Gas price. Yep. Yep. You can specify gas limit. Okay. But I want the gas of the other contract to be. I want to do this inside of a contract call. Not Ethers.js. So in this article, it said, and I don't see where they specify that gas limit at. And so you can specify gas limit for trash. For example, did ChatGPT write this thing? Because I don't see this gas limit being used anywhere. Am I missing something from this snippet? Hmm. I need some. Gas price of the transaction. Okay. I think with this call I can specify. Could I call this with a certain amount of gas? Maybe? Hmm. Is there a way to call a contract from another a set gas limit? I'm gonna have to send the gas price in the very beginning. I'm trying to do this. I want to do this directly in my contract. I don't want to have to deal with this from my externally owned account. Oh, wait. Maybe I can do that. Okay. Transaction gas price. So if we had an attack. Hey, nice. I'm guessing I would just make transaction gas price equals that number. I think I may be able to do it, but let's see. Is it installed docs? Oh, why is this not stated in a lot of places? Let's take a look. It probably is. I was literally just on this page. Gas price of the transaction. Yeah, no, this is cool. Learning a lot about some more Solidity internals. So that's how I'd be able to form a gas griefing attack. I could do somehow simulate the contract, place a few of those gas left, which would return, like if I were trying to simulate this, I would create a local contract. Yeah, if I wanted to do a gas griefing attack, I'd probably create a local contract and try to simulate everything accordingly. And then when creating, yep, I would throw these gas lefts inside of when we get to like that transaction that I wanted to cut out at, and then right before I send it, I would send transaction.gas price and set that equal to less than this gas left to successfully perform that attack. Um, but so I think I know how to get through this second one. I think I'll set transaction.gas price to be equal to this. I'll also put some loggers in there to just check it out and see and make sure that works. Um, Now, I don't know if when calling that, yeah, I don't know if when calling that transaction what would happen, but we'll figure that out. Um, okay, so get through that potentially by setting the transaction.gas price to be equal to this. Okay, next, what is this saying? So bytes a gate key. Don't know what that gate key is. So where the hell is this gate key at? Entrant would have to equal to okay, I see. So gate key is equal to my address converted to UNT 160 converted to UNT 16, which I'm not really sure how that would work. I would have to first pass in a UNT32, UNT64 gate key. It's got to be equal to UNT16, UNT64 gate key. Yeah, I'm not really getting this gate 3 part. I'm guessing I have to convert my address to a bytes 32. UNT32. this is a cool challenge. Um, so let's go back to our local. Address public entrant. And when do we make entrant is equal to transaction dot origin. So we have to make entrant be equal to, okay. So to make entrant equal to that, that's how we know we passed the challenge. So here's how I think. Send a transaction from a contract and not directly from an externally owned account. Within the contract, call enter with the address casted to bytes 8 and set the transaction.gas limit equal to 8,191 way. And that should possibly do it. If we call this bytes 8, the thing where I'm stuck is this bytes 8. I'm not sure why with all these conversions there would be an issue. So UN32, UN64 is the same as a UN160 casted to a UN16. I'm wondering if I have to do something weird like cast it in a UN160 first, and then a UN16, then a UN64, then a UN32. Like, do I have to just bubble it up? I don't know. Okay, let's look at some of the hints that they drop. So gas left. Hmm. There. What is this other one? This other resource they say. Oh, okay. Way of guessing on the call. Huh. Set feed public. Yeah. So I can just call that with this amount of gas. That's perfect. And there shouldn't be any, okay, that's cool. I don't know why I didn't just click on that link. There shouldn't be anything that, yeah, so there's no change of storage. This is just reading data, so we shouldn't have no issues there. Same here. So I can send that with this amount of gas. Bump the transaction thing. I'm just going to use that. It looked like the latest from the docs. I think the only issue I might run into now is this bytes 8 shindig. If I convert this to a bytes 8, in my eyes, we should be good. But do I have to do something funky like have a bytes 8 on the outside and then convert, like first it's converted to uint 64, then a uint 32. So let's look at that. Let's just take a look at casting. Casting. Casting solidity. The AI crypto token. Okay. Solidity is a static type language, so all variables have a fixed type. It is not possible to change the type variable after its declaration. Dedicate space for them. It is possible, however, to convert one type to another. It's called type casting. There are two ways to do this: explicitly and implicitly. But it occurs when the expression makes logical sense. I have to go check this dryer, y'all. Hold on. I'm back. Um, just to test something. Just to test something. Change my require statement. I need to figure out how to perform a gas sweep. All right, so I thought I had myself muted, but I didn't. So where did we leave off? Okay. Um, so conversions. You need to be very careful doing this season. Yeah. This is where we'll learn a little bit about I think shift when we convert certain bytes. First bytes are kept, and the last one if converting byte types. I wonder if we can probably just yeah, we can probably simulate this honestly by getting my address and then um, doing this by yeah, we can probably get the address, the bytes 8, convert that to a uint 64, then uint 32, and then also convert that to uint 16 and uint and do the same conversions, right? And then see what we get. I think that would be a good preliminary thing to try because I want to make sure that we get all this stuff performed properly. So I'm wondering if what's happening here is certain numbers are lopped off and it's going to be like a certain group of numbers and we have to pass that in as bytes 8 to the point where it passes all these tests here. So This dude got some, always got some heat. Follow them. Ah, okay. Unit 32A is gonna have this thing. Left padding occurs. So I wonder if what I have to do is look at these values and see how I may need to pad how I need to pad them. I don't know how to do that, but we can learn. Okay. Okay, I might have to read through this one. Hmm. Mm, 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 mm. And what I may need to do in the local version is actually remove some of these modifiers and no. Instead of making it just a requirement, I can just log. Yeah, I can just log it. So that way I can construct. And I don't know, maybe I just need to learn some more about like how bytes work and maybe how to convert them, how to shift some things. What I'm gonna do is duplicate this. I'm gonna call a test. Actually, let's not change that up. Let's keep gatekeeper one and just import a logger to it. I think it's Hardhat console.log. So what do you mean? Right. Okay. Gate 2 complete. Gate 3 A complete. Gate 3B complete. Okay. So this is going to let us know where a transaction may have reverted at, the whole nine. In attack, we're going to do a few things. So we're going to have gatekeeper. So first let's do import gatekeeper 1.sol. No. We're going to call this gatekeeper 1 contract. Yep. Okay. All right, so we have the gatekeeper contract. Now what we're going to do is call gatekeeper1 contract.enter. And we're going to enter that with how big is bytes 8? Gas is going to be equal to this right here. Bam. Then we're going to enter, okay, our key that we pass in. So that should be bytes 8. All right, so that should Can I just just dot sender? Okay. Can I just convert um let not let but bytes 8 key this is gonna look interesting. What the hell's bytes 8? Bytes 8 of owner. Is that gonna throw an error? Sure does. Cannot convert address to bytes 8. I also may just be wrong about my assumptions here. Transaction.origin. I think he's supposed to be type bytes. Oh no. Hmm. Waiting between bytes X and Interesting. So I had a feeling the way I was looking, I was probably going to wrap it in something like this. So if I convert UN 16, UN 160, if I work backwards, I'm really not gonna want to look up this answer after our next session because I'm really having a lot of fun working with this. Um, so we have a uint 16, uint 160. Convert that. And to first convert it to a bytes 8, I have to do where did that thing go? Convert address to bytes 8. So uint 64, uint 160, bytes 8 of that. And looking at this, uint 16, uint 160. Okay, so let's just do this. I want to know, how do I get to this level of knowledge? I guess I have to really understand hex digits. Yeah. Okay. My add-on time, about an hour and 23. Remember, I don't do longer than like 3 hours. So, first off, I'm not even gonna mess with that. I'm gonna just do step by step. Let's make sure we get this in order. So, before we even I'm just gonna pass like a random bytes 8 data. Not even gonna pass anything here. I'm just gonna say hey, wait a minute. Why did it all of a sudden say we couldn't? Not allow from address 2 bytes 8. But here, okay. Test. Okay. So let's set this up locally so we're not wasting any gas. We're going to do a few things. We have, why am I editing that? Let's just clear this for a second. Okay, so compiles. Okay, we have attack. We have attacker. We don't need attacker right now. We're gonna have gatekeeper contract or gatekeeper 1 contract. It's gonna be equal to gatekeeper 1. Yes, you can. Type chains right here. What are you talking about? So, before we're going to deploy everything, so let's go ahead and say, let's const there's die get factory. Oh, wait. Get. Do I not even have ethers in here? Ethers. Hardhat. Get contract factory. And it's going to be called gatekeeper 1. Deploy. void. Okay, we gotta do the same thing. Attacker contract factory. Wait, ethers dot get contract factory at attack, and we're going to say attacker contract is equal to wait ethers or no attacker contract factory dot deploy, and we have to pass an argument. Oh wait. Now this should be screaming errors at me because we didn't supply the I may have messed something up here because I'm getting a lot of errors for some odd reason. Says type chain is unknown, which that should not be the case. Okay. And we are in our local, right? Yep. Okay. Send a transactional contract. All right. So what we're gonna do is call attacker let dot deploy. Wait. Dot. Oops. Tag dot wait. Okay. That's going to be the receipt. Console.log. The receipt shows I actually don't even know if I need the receipt stuff just because I have my console loggers telling me some things, but let's just test it out. So yarn, hardhat, test. We're gonna do contract attack local. What? Oh. It's yarn, hardhat, test, contract attack, local. Okay. Okay. So we made it to gate 1. transaction rate without a reason string at gatekeeper 1, gate 2, 16. Okay, so we said gas left is the percent %s or whatever the heck we gotta do here. And we did this gas left function. What will we get? Four two one six. 4216. So that's because the transaction has taken up a certain amount. So we need to do isn't there a way to estimate a transaction call? Actually, let's test if console logging. Let's test if console logging takes up anything. Let's try it. So this does take away some gas. Interesting. So what if we just count all this out? Looks like the console login is actually taking up some gas. So if we actually send a regular message, let's see what we can make it to. It would be to see what the gas left is right here. 7. So did we do need to do? Do we need 15,900? When we were first doing that, I think we were getting 7709 at the very beginning. All the way back up here. Yep. So I guess that transaction is costing that much. So let's do 15,900 in the gas. I don't know how much it's gonna be on Sepolia, but we can try this attack and just test it out. Oh wait, I think you can simulate. I think you can simulate the call. So I may not have needed to do it that way. Simulate. Yeah, how do you simulate a transaction? Uh, it looks like I might be coming up on 2 hours, so I might have to break y'all, but gas left. There's no way to like predict the gas price of the transaction. That would be cool to do. Is to say, actually, I just want to see. I want to see what happens. 81, 8, 1. I want to see what happens when I do this right here, and I console log transaction.gas price. Let's see what that looks like. What? That's how much the gas price of the transaction is? Does it show anything different here? So we need this. plus 819, what is it? 8191. So this should be, goodness gracious. Why you let me just copy that? Oh my gosh, okay, whatever. Um, Google got me. So this is what the gas price should be. Bam. And the reason this one was wrong, it looks like, is because, yeah, I don't know, I was setting a specific one. Oh, we'll see. We'll see where we get to. Let's go to gatekeeper 1. Let's not use this. Let's go here. Let's go here. Should make it to invalid part 3. No. Okay, now I'm a little confused. Okay, so let's backtrack. So it really is supposed to be 8191 plus the 7709. I think that's how much this thing cost. And we're gonna test it, and it's not gonna work because our console log is taking up gas, but it should tell us that it's equal to 8191. Nope. 15418. So if I only send this joint with 8191, how much gas is gonna be left? $7709. If I take 8191 minus 7709, the price of the transaction, the cost. Oh, so that gets transaction dot gas price, not transaction dot gas cost. Okay. So that's 482. So 8191 plus 482. Nope. I see why I was seeing things wrong. Okay, 8673. So we make 8673. The gas limit left should be that amount. 8191. Okay. Perfect. The reason it doesn't work is because yeah, the reason it doesn't work at this point in time is because of this console log cost. So what we should do, leave that alone. I'm trying to think of how I would have figured that out without this case. Like, say we're trying to do a live attack. Oh, never mind. Because that transaction. Yeah, I think it'll always be the same. I think it's just the network will be different. So how much gas would be to get your stuff sent over fast. But I think if you set the price, it's fine and dandy. Depending on what's happening with the storage or whatnot, should be the issue there. So okay, so we should pass this gate 2. And I don't know if this is going to work on Sepolia. I could actually try to simulate that, but it may work. It may still work. So let's go ahead and see in our error logs. We should make it to this invalid gate 3 part 1. Nope. At gate 2. Why are we still having an issue here? I don't have any console logs. Should I take this out? Gate 1 works. Gate 2 does not work. Let's take this all out. ain't loving reaching. Don't you feel those scared? Do you? Do you think you love me? Some odd reason this ain't working. Why is that? We entered the amount of gas we needed. And even when we get to this we get through here, we get to here, and gas left is different. I wonder if that's because of when this require is called, how much is it? Okay, let's look up. I just read this today. This is cool. Figuring out which is which. And I may be doing this all wrong of like going about making sure we calculate this gas price correctly. Homies online say it's 23. 603. A696. So A696. So the price is going to cost some. The price of the transaction is going to cost some up until we get to that point, and then we have to account for the require statement. TS. Nope. Wait a minute. Wait a minute. Wait a minute. Wait a minute. If I did 0, let's say I did, what if I did a small number mod 8191, right? So like, let's say I just had, I don't know, 8,000 in this. 8,000, but it's just not gonna have enough gas, so um yeah, country call ran out of gas. And then when I do 8191, what happens? I just want to fuzz this. So when I call this, let's say I enter 8191, right? Call tag. This gas price should be set to this. So whenever I call console, let's import Hardhat console.sol. The transaction gas price is let's do it here. Yeah, let's do that here. I want to see what this transaction gas price is here. What? Did I mess it up? Send S, yeah. Console log transaction gas prices. This should. What? How does this not work anymore? Oh, that's why it's not working, because afterwards. Uh, it's because it's reverting there. So that means what's happening is it's getting overridden. It must be getting overridden by my config file with my gas price being set so high, I feel like. Because if I do this here, let's say 167, yeah, 16. That means it's not taking into account what I put right here. So if I just let that go, okay. One six seven, exactly. So it wasn't even taking into account my gas price I was putting in apparently. Um, I don't know why. Now, what if I automatically made, what if I just made that right there? What would that do? What? I don't know what that means. Okay, so we learned a little bit about gas. This is the part I love about tinkering and just running into constant walls. Um, you learn something about how things are working. So, where are we at on time? Ooh, we hit past 2 hours. So, because it looks like that my transaction price is this amount here, right? And if we do, let's say we just do gas left here, gas left. Take that, multiply that by, multiply this by 8191, I think it is. And now that I think about it, I don't think I can influence this value. For some odd reason, I can't influence this value unless maybe I can change my configs. What if we did that? Yeah, maybe let's do that and see. Because to be honest with you, this ain't working. This is not working for me. So what happens when we leave this? Does this number change? Yeah, let's see if that changes. Huh. So that wasn't it. What about here? Oh, this is on Sepolia. This is not even using any of this. Because this is for Sepolia specifically. So is there something happening under the hood? Gas left 285. If we do attack and enter, let's say we try to enter a gas price of 500, what happens? Wait a minute. So it does work. The gas left here. So when we get here, gas left is 8191. So how in the heck is it that after, if we leave this out, this require statement does not work? So let's say let's take this 8673 plus 23, which I think that's what we had. I think I had that last time. I'm pretty sure I had that 8696. Okay. Yeah, y'all, I'm gonna have to will you ever start reading audit reports on live stream? Yeah. Um yeah, no, I'm definitely gonna start trying to do that in some of my later sessions. Um I should be doing them in between my CTFs, honestly. I've just been kind of heads down trying to figure out all these CTF challenges, but I'll definitely do that for sure. So yeah, thanks for feedback, man. So here, I think I'm gonna be wrapping it up soon because I've been streaming for about 2 hours trying to get this, at least get past gate two, and I have been stuck. So I think what I'm gonna do is read up some more on um, read up some more on like gas left, understand what's happening whenever I get to this execution statement. So test that out. That a reason string. Yep, yep. Yes. Test that out and then I'll hit that. Okay. So let me see. Whew. But this is basically what hacking is. You hit a wall, try to figure out something, try to pivot, and go from there. So let's see. 8696. How was I did this? Okay. I think that's the issue here is understanding how much gas a certain thing takes up. Like I wish I could step through. It probably would be best if I was able to step through the code to see hmm. Okay, so yeah, y'all. I'm gonna call it here for this stream and work through. So since I'm at currently 2 hours and 24 minutes. My rule of thumb is after about 2 hours of trying stuff, look at it right up. So I think what I'm gonna do is I'm not gonna look at it right up. I want to read a little bit about this gas left because I honestly don't know. I mean, I know what's going on, but um, I clearly don't know enough to figure out why I'm not able to get past this. Why I'm not able to get past this particular gate. So I'm going to read up some and come back to it. And in our next session, if we go about like an hour into the problem and we can't figure it out, then we're definitely going to be looking at it right up because you get to a point in CTF challenges where you just are just wasting time and hitting a wall and not actually learning anything. I think that's what I've been doing for the past 20 minutes. So yeah, thanks for tuning in for this session. I will catch y'all back in the next one.
Nothing I can do with a woman like you. It gets my temper cool like the breeze, 'cause I'm any kind of way to say what's on